Hello friends, today we will learn how to do curve fitting in Python. So in this video we will mainly focus on the polynomial fits, and in my next video I will cover the curve fit. Okay, so this will do the polynomial fit, but in curve fit you can do some more general things like exponential fit or something like that. So in this video we will basically focus on the polynomial fit. Okay, so let me first make some data which will we have to import the data, and then we have to do some fitting. Okay, so for creating the data, let me first write a Python script which is called data.py. Just it is a name, you can give it anything to it. Okay. So first of all, let me import numpy as np, and then create linear space which is named as x. So this linspace is a function of numpy, so this numpy dot linspace, and maybe I can create the -1 to +1 with 100 points. So this is my linspace, and y is equals to some polynomial function, maybe x to the power 5 plus 3, not 3, 4 into x to the power 3 plus x maybe, and plus 5, let's say. Okay, even not 5, even I can write just something else, so maybe 2. So this is a fifth order polynomial simply. So now let me just open a file which is named as out.d. You can just even use text file also, txt file. So, and in write mode, so w is for write mode, and now I am just opening this file and I am just calling it f. So f is a file variable. Now let me write a loop for I in range, and this should be go up to length of x, and in the loop I am just writing that f dot write. So this means the write function will work on this f file, so that means out.txt file. Okay, so now within this I just double quoting, and I want to print two numbers. So one is the x, another is the y. So I am writing percentile 1.5 e. So this 1.5 means after the decimal place, it will be 5 decimal, it will be up to 5 decimal places, and e means this is will be in scientific format. Okay, so then backslash t, that means a tab, and then again another 1.5 e, and then finally I am writing this backslash n, that means a new line. So, and then I have to specify which numbers will be printed in, printed there. So for that, let me just make a tuple that is xi comma yi, and that's all. And this I can just save, and this will create some out.txt. Okay, so some invalid syntax, this okay, so got it. So this comma will not be there. Okay, and yeah, now it is working. So you can see that by listing that you have some out.txt, and you can just check it out that is it working or not. So you can see that the first column, it is containing x, so this is -1 to +1, and you can see that this is the function. Okay, so this second column is the y value, the first column is the x value, and second column is the y value. So now I want to write another file for polynomial fit. So for that, fit poly, this is just a name that's all. Again fit poly dot pi. So yeah, now let me import numpy as np, then just load the file. So f is equals to np dot load txt. So this is very easy. Load txt function is very easy to store the data file if this is the purely numerical data, but if you have some comments, you can just use comment or comment option also. So for now I don't use that. So out.txt, and then this quotation w, that means this is in the, okay, so I don't need because I'm just reading it, so it will load. So now in this f is a two-dimensional array, so you can see that by printing this is a two-dimensional array. So in this, okay, sorry, so clear, yeah. Yeah, so now I want to store the x data in my x variable, so this will do this, because if the first index is the colon, so that means all the row, so all the row of the 0th column, so this is the 0th column, so all the row of 0th column is x, and y is basically the first column. Actually the 0th column means the first column, and 1 means the second column actually, so it will get back the data. Okay, so now it is imported, the data is imported in x and y variable. So now what we need to do, we need to import the polynomial polyfit. So polyfit actually is in the numpy, so I can just call from the np. So for that, let me just use p. P will store the coefficients of the fitted polynomial. So p is equals to numpy np dot polyfit x comma y comma how much order. So let me just do the exact thing, the fifth order for this. So yeah, now you get that coefficient. So print, oh, not print here, okay, sorry. So python fit poly, so you can see this is the thing, so this is the coefficients of your data. So now let me verify it. So for that let me import the plotting library. So import matplotlib.pyplot as plt. So now, okay, so before I plot, so I need to store another array. I have to store the fitted data. So that means what? So I want to create another polynomial which will be using this p, not the actual data, so which will use this fitted data p. So then I can just check it out that is the fit is correct or not. Okay, so yeah, so for that, for I in range length of p. Okay, so one thing I should mention that in p, so the first element will be the coefficient of the highest power of the polynomial. So for that, let me create some variable z is equals to 0, initialized with 0, and then z plus equals to pi, and pi means 0. So and if you fit with this polynomial fit, then the fifth order polynomial means the P will have 6 elements, because it will contain the power of up to the, 5, and also the power of 0, that means the constant variable, constant term. So that means actually that p0 x to the power 5, p1 plus p1 x to the power 4, in this way. So this is how it will go up to p5. So p0 to p5, so in p5 it will be x to the power 0, so that means p5 is the constant term. Okay, so pi multiplied by x to the power so it will be length of p minus I. So length of p is 6, minus I means, so for the first term, let me verify that for the first term this will be I, so I is equals to 0 for the first value in the loop, it will be 0, I is equals to 0, so p 0, and then length p is 6 minus 0, that means 6 minus 1, so it will give you the actual power. Okay, so for this, so because you can just check it out that when it will be the I is equals to 5, because it will be 0 to 5, so length 6 means 0 to 5, so so when it will be 5, then this is 6, length p is 6, minus I is equals to 5, so that means 6 minus 5 is equals to 1, and 1 minus 1 is 0, so you can see that it will give the correct thing. So now I want to plot, so this plt dot plot x comma y, this will give you the actual data, and I am just making some marker with marker plot, because I want to see the data as points, and I want to draw the fitted curve with some solid line, and because there is 100 points, so I'm just using this mark every option, so it will mark every 5 means it will mark the data points with some after some, actually I don't need that. Okay, so it will basically plot the data of skipping 5 data points. Okay, so that is what, so I'm just, for now I am just keeping all the data, so mark every one, so that, and then plt dot plot the fitted data, so x comma z, and then I want to show the plot, so just show, and now you can check. So you can see that the orange curve, actually I can just that is why I was using mark every, so this is highly dense points, so you can see that the blue points and this orange line is coincides, so they are coinciding, so, and just use mark every maybe 5, then it will not plot every data. So yeah, now you can see that this line is coinciding with this data point. So this is how you can just fit with some polynomials. Okay, so if you have some data and you want to use a polynomial fit, then you can just use this polyfit function. And also, if you just very curious about this p, so you can just print the p, and okay, so now yeah, I'm just closing this plot, so you can see that if I remember the data, that was x to the power 5, so that is why this is the first element, this is 1 almost, then there was no x to the power 4 element, then it was 4x cubed, so this is almost 4 and x to the power 3, then again this is minus 10 to the power minus 7, so that means it is almost 0, so again, so there was no actually square term, then the linear term was x, so that is why this is 1, and the last, the constant term, was 2. So you can see that you can verify that this is actually working perfectly fine. So that's all. Thank you and subscribe.